NASA is all geared up to create history by opening a new era for the solar system. After traveling in the vacuum of space for nearly 9 months, NASA's double asteroid redirection test mission is ready for impact. The spacecraft, on a mission to test a technology that could be used to deflect an asteroid coming towards Earth in the future, will crash into Dimorphous, a moonlet of the asteroid Didymos. What's more exciting is that NASA will be live streaming the impact later this month, so that you can enjoy this cosmic bombardment while sitting back comfortably at your home. But let's save that for later. Today we are going to talk about how NASA plans to slam its probe into an asteroid, so stay tuned. In a few weeks, NASA controllers will deliberately crash their $330 million DART robot spacecraft into an asteroid. The half-ton probe will be traveling at more than 4 miles a second when it strikes its target, Dimorphous, and will be destroyed. The aim of this kamikaze science mission is straightforward. Space engineers want to learn how to deflect asteroids in case one is ever discovered on a collision course with Earth. Observations of DART's impact on Dimorphous's orbit will provide crucial data about how well spacecraft can protect Earth from asteroid Armageddon. Impacts by asteroids and comets have had big effects on life on Earth in the past. The best-known collision occurred 66 million years ago when a 10-kilometer-wide asteroid struck Chicxulub on the Yucatan Peninsula in Mexico. The collision created a blast that had the energy of several billion atomic bombs and led to the destruction of 75% of all plant and animal species, including all land-based dinosaurs. Since then, films such as Don't Look Up, Armageddon, and Deep Impact have depicted similar devastation being triggered by asteroid or comet crashes in modern times. However, astronomers believe it is unlikely we will experience such catastrophic impacts in real life in the near future, as NASA's double asteroid redirection test spacecraft is on its way to test a potentially life-saving planetary defense technology by crashing into an asteroid. The spacecraft has now captured the first images of its target double asteroid system, which includes the asteroid it will crash into, called Dimorphous, the asteroid moonlet of Didymos. Scientists say that these objects are hurtling through space and time, of course, scarred the Moon and over time also on Earth, have had major impacts and have affected our history. They claim that a series of new missions put in place are actually helping them understand and quantify those threats in an unprecedented fashion. DART is the first mission to try to really bump out of the way an object of threat in a direct experiment. Scientists have identified and mapped the orbits of nearly 30,000 asteroids that rattle around the solar system in Earth's neighborhood. All of those space rocks either never cross paths with Earth or are so small that if they did, they would harmlessly burn up in Earth's atmosphere. Still, it's possible that an asteroid impact in the future could harm Earth, and planetary defense experts want to be ready. The theory goes that if scientists ever detected an asteroid on a collision course with Earth, an impactor probe could realign the orbit of the space rock, ensuring that it crossed Earth's path when our planet was a safe distance away. But scientists don't want to work only from theory if the situation arises. That's where DART's dramatic destruction comes into play. The spacecraft will slam into a small asteroid called Dimorphous, which, like clockwork, orbits a larger near-Earth asteroid called Didymos every 11 hours and 55 minutes. However, neither asteroid poses any threat to Earth, and DART won't change that. The DART impact should adjust the orbit of Dimorphous, cutting its circuit by perhaps 10 minutes. Once it is slammed into Dimorphous, NASA will make observations of the asteroid from Earth to ascertain whether the spacecraft was able to alter the asteroid's trajectory significantly. If it does, that means the method can be used to avert potentially hazardous asteroids on a collision course with Earth. The double asteroid redirection test is a demonstration of kinetic impactor technology, hitting an asteroid to adjust its speed and path. DART will be the first ever space mission to demonstrate asteroid deflection by a kinetic impactor. The data from the crash can help scientists create mini impacts in a lab and build sophisticated computer models based on those results. Scientists on Earth will be spending weeks after the impact measuring the actual change in the moonlet's orbit to compare with their predictions. The work will refine scientists' understanding of how asteroids respond to impactors and help to tune any future missions to the necessary amount of orbital change. Nancy Chabot, the DART coordination lead which runs the mission, said during the news conference that this isn't just a one-off event. We want to know what happened to Dimorphous, but more important, we want to understand what that means for potentially applying this technique in the future. While the stakes are low compared to any scenario that would motivate a real asteroid deflecting mission, the difficulty, however, is the same. This is incredibly challenging, as the spacecraft will only be able to see Dimorphous itself about an hour and a half before impact. So according to scientists, this is a par 1 course, so they're going in for the hit this time. But what's going to happen if something doesn't go according to plan? Mission personnel are pretty confident that as long as the spacecraft hits its target, there should be something to see. So if DART collides with Dimorphous and then we don't see any orbital period change, it would be exceptionally surprising, because the amount of momentum that DART is bringing in on its own from the weight of the spacecraft slamming into Dimorphous is enough to shift its orbit in a measurable way. However, missing the moonlet is still a possibility, but that's kind of the point of DART, to work out what would-be planetary defenders need to know if they ever want to launch a real asteroid deflecting mission. Andrea Riley, a program executive at NASA working with the agency's Planetary Defense Coordination Office, said during the recent news conference that this will give us all confidence that deflection technology could work in the future. Even if it misses, it still provides a lot of data. This is a test mission. This is why we test. We want to do it now rather than when there is an actual need. While engineers were unsure if the spacecraft would be able to see its destination from that distance, the composite image revealed Didymos in the darkness of space and pinpointed its location. The new images released by NASA show light reflecting off Didymos and its orbiting moonlet Dimorphous. They are a composite of 243 images taken by the Didymos Reconnaissance and Asteroid camera for optical navigation on July 27, 2022. The DART spacecraft took images of the asteroids from approximately 20 million miles away, and navigation camera experts were uncertain whether DRACO could spot the space rocks from that distance. But one thing we've come to know over the years is that one should never doubt NASA's abilities. The first set of images is being used as a test to prove NASA's imaging techniques. The quality of the image is similar to what we could obtain from ground-based telescopes. But it is important to show that DRACO is working properly and can see its target to make any adjustments needed before we begin using the images to guide the spacecraft into the asteroid autonomously. The images are significant, since the spacecraft will depend on this ability to see and process images of Didymos and Dimorphous once they also can be seen, to guide the spacecraft toward the asteroid, especially in the final 4 hours before impact. Seeing the DRACO images of Didymos for the first time, we can iron out the best settings for DRACO and fine-tune the software. In September, we'll refine where DART is aiming by getting a more precise determination of Didymos' location. Ultimately, the DRACO system will be used to help the DART spacecraft navigate and slam into its target autonomously once it gets closer. NASA's DART team explained that the new images would help them to fine-tune the software responsible for those final hours before impact. So, when will this cosmic collision take place? When will the DART spacecraft slam into its target? It turns out that you don't need to wait long. If all goes to plan, DART will ram into Dimorphous at a speed of 15,000 miles per hour. The DART spacecraft will smash into Dimorphous on September 26. It will do so by conducting the very first test of the kinetic impact technique, which utilizes a spacecraft to deflect an asteroid for planetary defense. It will also be the very first planetary defense test conducted in space. Dimorphous doesn't pose a threat to Earth, and it will only be used as a test subject, standing in for a hypothetical hazardous space rock zipping towards Earth. Well, that sounds reassuring. It's been an exciting few months for space news, with the release of the first image of our galaxy's black hole, Sagittarius A star, in May, the first JWST images in July, and the upcoming launches of NASA's Artemis 1 mission and SpaceX's Starship. The culmination of the DART mission is another impressive milestone to add to the list. After the event, it won't take long for experts at NASA to know whether humanity has an asteroid diversion technology at its disposal. So what are your thoughts on this? Do you think that in future, missions like DART can succeed in altering the course of a giant asteroid bound to hit Earth? Let us know in the comments below. Thanks for watching. Be sure to like and subscribe to Arc Eternity to get interesting content like this. Turn on the notifications so that you never miss any exciting news.